Hello, this is Jim Sutton with Stone Tablet Innovations. Today we're going to do video blog number 5, where we're actually going to run a C program, Hello World, on the Espressif ESP32. So the goal of this video is pretty simple. When we're all done, you should be able to run a Hello World program. And we're going to do it on a Windows 10 computer with a target of the ESP32 chip. So our prerequisite is installation of the development foundation, and that's described in my video blog number 4 in pretty good detail. And this video is going to follow the approach and steps in the Get Started Espressif tutorial. Here's the link, and there's also a link in the notes. You can just copy and paste. Just one more time, the target hardware is the Espressif ESP32 DevKit C-32D. So we're going to jump in to step 4. Steps 1, 2, and 3 had to do with setting up the environment, the IDF, and now we can actually get started. So the installer created a shortcut on the start menu in desktop. I've got an arrow showing it to you. Double click on the icon to open a command window, and it will automatically set up the required environment variables. This will really prove that all the installations went correctly. So here is the result of running that command script, of double clicking on it. And you can see where it's made pass to the extensive compilers, to CMAKE, Ninja, and Open OCD is, we're not going to use Open OCD in this thing, but that's if you wanted to do hardware debugging, it would be there. So these are all the paths that are opened, and you're all ready to start building a program if this thing executes correctly. You see on the left, I've also put a little command, and I think it's good to keep that in mind whenever you're confused about what your paths are. This is a good command to use because it will list the paths in one per line, which is actually readable. If these are all jumbled together, you really can't see. So now we're on to step 5, which is actually starting a project. We're going to go ahead and create a project that we can run on the ESP32. So we need to build a directory. So we're going to open up our file explorer, and we made this ESP subfolder under my main user, and I'm going to put a new folder, and I'm just going to call it STI projects. And that should be so we have an STI projects now. Now, right now, if I double click on it, there's nothing in this. If I go to examples, they have a whole bunch of preloaded examples. The one that I wanted is in the Get Started subdirectory, and it's just called Hello World. So I'm going to copy that directory, and I'm going to go back into STI projects and paste it. So good. Now I've got a Hello World, and we'll look a little bit more at these files later. And in the main is actually the Hello World main.c, and we'll be running that in just a second. I just want to show, I did this in Windows because it's so much easier to click than type, in my opinion. I'm just going to close this here, but if we launch this command window again, it brings us into the ESP subdirectory. So I can do the STI projects, and you can see when I do dir, the directory, you can see the hello world file is right in here. So now we have to go back and do a little bit of hardware reminders, and the DevKit C32D is a dual core extensive 32-bit LX6 MCU, and I want to call attention to the boot button on here, because we're going to need to press that to force it into a hardware load situation where we can load and start a new program, and I'll show you how that works in a little bit more detail. But I just wanted to show you the location of that. And again, in a reminder, I'm showing mine on the DevKit C on a breadboard by Global Specialties. And again, I think it's good to find one that's pretty wide, because this chip is wide. And I've got a couple of jumpers in here to show it hooked up to an LED for the blinking. We're not going to use that right now. This is just to give you a general idea. But we do have this power programming cable, and you can see where one side is a micro USB, and the other side, which you can't see in this picture, is a USB 2.0, where I've plugged that into one of the ports in the Windows 10 computer. So we're going to install the ESP32 now, and first I'm going to open the device manager, and the easiest way to find it is to type it in to the search window. Okay, here we are with the device, and you'll see a number of parameters that are listed here. Right now we don't have any COM devices installed in this list, and hopefully that's going to change when I plug in the USB cord into my computer. Okay, now we've picked up a ports here for COM, and we see a Silicon Labs driver for CP210X, and that's excellent, because if you look in the documentation for establishing the serial connection, the ESP32 DevKit C, which this is, wants a CP210X driver. So we've installed it, and it's working properly. Now, I want you to notice up here in this sentence, Silicon Labs CP210X USB to UART bridge, and then parentheses COM3. We're going to have to remember that, because we're going to have to make sure our program talks to COM3. And right now it's set at 9600, but we're going to override that, and you can get the driver details if you want. But that went smoothly. You can see now that it's all installed. We have a driver now that we can talk to without too much difficulty. So now we're ready to do some final configuration and build the executable file. And Again, you need to open the ESP-IDF command window to get the right paths, navigate to the Hello World directory, and here we go. We're going to navigate to the directory, Hello World. So all we have to do is change directory. I did STI projects. And find a directory. I'll see that there's a Hello World, so I'll go change directory. Hello World. Now we're in the directory, and we want to set the target to be ESP32. So we do idf.python set-target ESP32. And it's working right now. As soon as this completes, we'll run the menu configuration program. All right, so it's written some build files to hello world.build, which is perfect. So now I can run menu config. And you can navigate through the various options. So most of these, I don't think we need any configuration on this particular item, but when we get into the flasher, you'll see that this utility will have options we can set. But let's look under the SDK configuration tool. It says Extensa ESP32 compiler toolchain looks good. And I hit escape to get back. And when I'm all done, I can press save, and my configuration is complete. And I'm going to go ahead and close this device, and I'm complete. Okay, now we're ready for the final pieces of building and flashing the program. And we're going to go ahead and build this project now. And it's pretty simple to do. You go idf.python py build. And it's going to go do a lot of work here. And it's finding the various compilers. So it's finished configuring. And now it's busy building 940 C objects. And this first time you run it, this is obviously going to take a little bit of time, not too long. but subsequent builds will go quicker because the Ninja linker is smart enough to only do what it needs to. It's an incremental linker. It only does what it needs to. So we've now built the project and we're ready to go ahead and flash it onto the chip, which is fairly easy to do. We go idf.python/-port com3-baud 115200, and we have to use the word flash. So when I hit enter, it's going to try and talk to the ESP32 board, but it won't actually start loading the program until the ESP32 has said, I'm ready. So I'm going to make it get into a bootloader mode by pressing the reset button, and I'm going to tell you when I actually press this by saying I'm pressing it now. So here we go. So it says it's connecting, so I'm pressing it now, and so it's busy writing 20%, 40%, 60%, 80%, 100%. So this is fully completed, and we've now loaded the program onto it. In a minute, we'll run the program. So now we're going to go ahead and see what the hello world actually looks like. We just loaded it with the flash loader. So to monitor it, we do idf.python-port com3-baud 115200. Probably don't need to do this every time, but it's so much in my head now, it's just simpler to type it and monitor. So now what we're seeing is the program is saying, hello world, this is an ESP32 chip with 2 CPUs, cores, Wi-Fi, Bluetooth and Bluetooth low energy, Silicon revision 1, 2 megabytes flash. And then, so it gives us that header, hello world, and who it is, and then it counts down to 0 and then resets itself and starts all over again, and it will keep doing it. This is about the simplest program you could imagine. And so we're running, it's going well. In the next slide, we'll take a look at the program itself after having viewed it working. So we were able to get a running hello world on the ESP32. On the right here, I printed out using the Atom text editor what's actually in hello world main.c, which I showed you earlier is the C program we're actually running. It shows how we're linking in, including free RTOS and some important system files from Espressif. And in there you can see where it checks for the silicon revision and the amount of flash. You can see where it does the countdown and where it does the restart. So that's about it. We've made the very first program work. We have a working development environment, and I hope you're successful as well. So just want to close by saying thank you for listening to this 20-minute video. I hope it saved you some time.